Okay.
That's why I need to
Fine then.
restart the router. That's
Eh,
why it become late.
Fine. So see, Hemant, one thing is there. You were saying I was unable to understand what you were saying there in message because actually advanced preparation is only with the questions.
So means I'm saying,
Concept is same.
so means I'm
Concept is
saying
same.
that
Huh?
sir, I'm saying that so first we do concept, then 2 days like that advanced level questions like that. I'm saying.
First we need to see actually whatever the questions we are doing. Those questions are only conceptual. Without going through them, nobody is able to directly go jump up to the advanced level.
Yes,
That's
sir,
impossible.
we will go in that
We
manner
will
only.
try. We will try. We will try. We will uh, solve the questions of advanced level as well. If you
Yes, sir.
wish, if you wish for the advanced level, see, I have to make sure that the concepts are clear. And for the
Yes, sir.
concepts, you have to solve the basic questions. Without that, theory is vain. So, wait a minute. Uh, Let me send you a book. Share.
Yes, the screen
This
is
is the screen
visible, sir.
visible.
No, it is
Fine.
visible,
This
sir.
is
No
that
issue.
book. This is the book which I have sent to you. Okay. This is Physics for JE Advanced by Ashish Arora.
So this book is for uh,
JE
problems or
Advanced.
concept problems or
This is
concept.
not conceptual book. This is only for problems. Only 700 problems which are of JE Advanced level are given in this book. And several problems you will find that we have taken in our class as well.
Only for problems I need to follow this book.
Yes, only problems are there in this book, nothing else. And all
Yes.
these problems are of JE advanced level. Good problems, they are all good problems, okay? Fine. So this is of magnetic flux. We are on capacitance, yes. Yes, this is the capacitive circuits. Solving the capacitive circuits, we will see them later. Yeah, like this flux through a circle. All these questions, they are taken in the classroom. Okay. So this book, please download it. And if you want, you can buy it also. Or if you wish, if you can, then use this PDF. Okay. Now, let us start. Where were we in our last class?
So we need to start as electric fields.
Electric field. Now, see this. Are you able to understand the concepts in this way? I am only proceeding so that we can focus more on questions and our speed will be fast.
Sir,
Fine.
no problem, sir. It's fine.
Is it fine? Are you getting the concepts? That's what I'm
Yes, sir.
asking. Are you getting the
I'm
concepts?
getting serious.
Fine. So now see this electric field. What is electric field? Electric field, whatever. whenever we say the word field, generally in general language, field means what? Field means where we sow crops. That area we call as field. We call as field. Now, similarly, this field is also a region. Only difference is that the normal field, which we were saying in day-to-day life, that field of field of that rice field is there, or field of vegetable is there. Okay, the field means that the region where you have sown a particular crop. Similarly, here, field stands for region, but only difference is that this region is three-dimensional region. In this three-dimensional region, you can influence the charge. So the region around a charge where its influence can be experienced, where its influence can be experienced by other charges. This is called electric field region. This is called as electric field region. It means electric field is present there. It means we are within the field of some charge because we are able to experience, we are able to experience the force due to the presence of some other charge. That charge we call it as a source charge. Okay. Now, next is electric field strength. So, what can we understand by this electric field strength? By this electric field strength, we mean that what force is experienced by 1 coulomb of charge. How much force 1 coulomb of charge is experiencing. Okay, that is the that is what that is the electric field strength. It is also called as electric field intensity or simply mathematical electric field. Mathematically, it is just electric field. That's it. Okay. At any point, an electric field strength will be equal to the force experienced by 1 coulomb charge. Means in a region, in a three-dimensional space, if we are putting 1 coulomb charge at any point, then what? Then the force experienced by that 1 coulomb charge, force experienced by that 1 coulomb charge is called as the electric field at that point, or you can say electric field strength at that. Getting it?
So it means so this electric field strength mathematical called as just as electric field only, sir.
Electric field, see, for mathematical purposes, how electric field, which we defined earlier, that it is the force experienced by. Now, experience is a subjective quantity. We cannot write it. Like you experience fear, I experience joy. That is a subjective quantity. We cannot write it down mathematically. So here what will we will write? Here we need some quantity. Now what quantity we are going to write here? So one thing we need to remember, for mathematical representation, we use a unit positive charge. So electric field strength is nothing but force experienced by a unit positive charge, that is 1 coulomb charge, when it is placed at that point.
Ah,
Okay. It means what? It means if 1 coulomb charge is put in any region, whatever force will be experienced by it, that force will be called field at that point. Okay. Got it?
so it should be only positive charge only. That means
Huh? What did you say? Yeah,
Sir,
for positive charge. For
sir,
definition,
what?
we use a unit positive charge. Definition of electric, see the definition of electric field density. Are you writing it down? Electric
Copy
field
it, sir.
strength, electric field strength at a point is force experienced by a unit positive charge at that point. Unit positive charge at that point. Okay,
Sir,
got it
but
now.
even if you take unit negative also, it will be same, but only sign will be changed, no, sir.
See, no. You are getting it wrong. I am just saying about the definition of electric field. Electric field will always be same. Direction of force will change, but electric field will always be same. Electric field is the direction of force experienced by a unit positive charge. So if you are placing a negative charge, then it will be experiencing force in opposite direction. But that will be not called electric field, because electric field is only the force experienced by a unit positive charge. So opposite will be the electric field. Got it now? Electric field is defined as force experienced by a unit positive charge. Do not get confused. Only remember that if positive charge is there, then its direction you will take as electric field. If negative is there, then opposite must be the electric field. Got it?
Only
Got
magnitude
it?
will be same, only direction will change, no? That's the thing, question.
Yes, direction will change. Direction will be different, but not of field. Field's direction will be same. Force's direction might be changing. Direction of force will be changing. Okay, but field will be changing. Got it?
Yes, sir, got it, sir.
Now, if instead of 1 coulomb charge, a Q naught charge is placed at that point, then what will happen? Instead of 1 coulomb charge, we are placing only a small charge Q naught at that point. Then what will happen? Then the force will be on the charge Q naught. But what is the magnitude of Q naught? It can be anything. And how can we write electric field? See, force on charge Q naught is F. Then force on 1 coulomb charge will be F upon Q naught. Force on 1 coulomb charge, that is F upon Q naught, is the electric field at that point. Force
Sir,
on
yours,
1 coulomb charge. Yes, what were you saying?
so mean they we need to specify the either the charge is positive or negative, no, sir.
See, whenever negative sign is not written in front of the charge, it is understood as positive. Got it? Whenever negative sign is not specifically mentioned, till that point we take charge as positive only. Got it? So here we are assuming that the charge is positive only. Got it now?
Yes, sir, got it.
Fine. Now properties of electric field intensity. First of all, it is a scalar is a vector quantity and direction will be same as that of force. Its SI unit is Newton per coulomb. Electric fields SI unit is Newton per coulomb. Direction due to positive charge, direction of electric field due to positive charge is always away from it. Whereas due to negative charge, it is always towards it. Taken down these points?
Sir, got it.
Now, fourth, Electric field follows the principle of superposition. This is the fourth property. Okay. Now, what do we mean by that electric field will always obey the law of superposition? Yes, we mean that the electric field at a particular point will be given by the vector sum of all the electric fields present due to different discrete charges at that point. Got it? Got it?
So if more than one charges are there, we can like say,
If more than one charge are there, then we will calculate electric field like this. In that case, the electric field will be calculated like this. Okay, got it now? Done. Shall we move ahead?
yes, sir, we can mention.
Now, electric field due to various charge configuration. Now, if a single point charge is there, see now, this is the derivation of electric field due to a point charge. This derivation is important as far as boards are concerned. As far as boards are concerned. Okay. Now, due to a point charge, what will be the electric field? If a point charge is Q, let us say that it is situated at point P. Okay. And at point P, what will be the electric field due to the charge small q, which is placed at this origin? How to get that? For getting it, for getting the electric field due to this charge, source charge q at point P, we need to find out the distance OP. OP is the distance between the source charge. See carefully. It is the distance between the source charge and the point P. It means the position of point P. It is nothing but position of point P. Got it now?
Source charge means we are finding the uh,
You
electric
want to
field
take it
due to
down or
this
I shall
charge.
move ahead?
Sir, I'm taking the answer. I copied, sir. Sir, here,
Let a point charge Q be the source placed at origin. Now consider a test charge Q naught at a point P such that the position of P with reference to O is given by the position vector R as shown. Now if F is the force on Q naught, then what will be the force? Force will be K Q1 Q2 upon R square. In vector form, we will write this force. What will happen now? Now, this force is equals to K Q1 Q2 by R square into R cap. Again, R cap is R vector upon R vector's magnitude. Okay. So in vector form, I wrote this force, and electric field will be what? Now the electric field will be force divided by the charge Q naught. Force divided by the charge Q naught. That will give me the electric field. Okay.
yes, sir.
Force divided by the charge Q naught. And when I will divide the force with this charge Q naught, what I'll get? This charge Q naught will just disappear. It will be cancelled out. And I will get KQ upon R square. KQ upon R square. This is the electric field due to a point charge. Got it till this point?
See, only electric field due to positive charge, sir.
Hmm? Yes, am I audible?
Sir, you are audible, sir. Sir, this is only electric field due to positive charge, sir.
Yes, electric field due to positive charge. See, we will study electric field due to positive charge only. But because negative charge also electric field's magnitude is same, just minus sign will be there. Just we will use negative sign instead of positive. Okay?
So that negative sign indicates the direction is opposite, we can say, sir.
Just direction is opposite. That's it. That's it. Done?
Sir, copy it, sir. Yes.
Copied. Now see this following question. Find out the electric field at a point A due to a point charge of minus 20 microcoulomb situated at point B. Solve it now. Yes, done. Hello. Yes, Chanak. Hemant.
Sir, find out the electric field at a point at 0, 1, 2. Sir, hello, sir.
Yes, what is the answer?
Look at minus 22.5 into 10 cube into minus root 2 I plus j plus k. Right.
See now, this is the solution. We know that electric field is kq upon r cube into r vector. Okay, this is the
Yes,
formula for electric field in vector form. We know that already. Okay, now how to get this r vector? For this r vector, we will write just coordinate of the point x cap, xi cap, yj cap, and zk cap. Okay, but do these 2 points are there? We have we have to find the electric field at A due to charge which is kept at point B. So what is the BA vector? This BA vector is x2 minus x1, y2 minus y1, and z2 minus z1. From here we are getting this r vector as root 2 minus root 2 I cap plus j cap plus k. And magnitude is r vector of this r vector is 2. Therefore the electric field will be finally minus 22.5 into 10 raised to 3 into minus root 2 I cap plus j cap plus k cap Newton per coulomb. Got it now?
sir, got it, sir.
Taken down.
Sir, got it, sir. Got it.
Fine. See this next question. 2 point charges of 2 microcoulombs and minus 2 microcoulombs are placed at points A and B as shown. Find out the electric fields at point C and D. Wait a minute. See now. 3 points are given to us. This is point D. Okay. Point A and point B. Two charges are kept plus 2 microcoulomb and minus 2 microcoulomb. Now, because of these 2 point charges, what is the electric field at point C and at point D? This you need to calculate. See now, in this question, we have two things. 2 point charges are there. 2 microcoulombs and minus 2 microcoulombs. When we calculate the electric field, we have to keep in mind the principle of superposition, which says that electric field will be added up as per vector addition. So at point C, we can clearly see that electric field at point C is in opposite direction. So it is going to be cancelled out. but it will not be cancelled out fully because positive charge is farther. This plus 2 is farther and this minus 2 is closer. So this field will be powerful. Because of negative charge, this field will be there, and because of positive charge, this is the field, blue one. So this field, they will cancel each other, but not fully. Positive one will have lesser effect, and negative charge will have larger effect. So the total field we will get just by subtracting. Okay. Now electric field at point D. For point D, we know that electric field will be in their respective direction, due to A and due to B. Now these two will have vertical components like this. These vertical components will cancel out. What will remain? Only thing that will remain is along the positive x direction. So the total answer will be 2EA cos 45. 2EA cos 45. 2EA is KQ by R square and cos 45 is 1 by root 2. Okay. So from here we will get our answer. From here we will get our answer. That will be what? Solve it and ultimately we will get our answer. Just calculation is there now. Okay. I think you can do it now. Now next part is of C. Now electric field at C will be calculated just by subtracting them. Electric field at B, electric field due to B is greater than the electric field due to A. That's why we subtract both of them, and ultimately 8000 Newton per Coulomb we are getting as the field at point C. Got it now?
Yes, sir, got it.
Got it. Okay, fine. Now my next class is there. That's why I have to leave. Please make
Yes,
sure
sir.
tomorrow,
Sir, tomorrow there will be no issues.
yeah, join the class within the time. Okay,
Yes, sir, okay.
fine. Okay, then from here we shall proceed